Hello everyone, how are you? This is part 2 of the basic English vocabulary rundown. So we're going to look at the different ways that science uses the English language and some of the most important vocabulary that you will need. So our first word in this part is molecule, a word we have seen before in the other parts, and a molecule is the smallest unit of a compound or a natural unit of an element. So these are all molecules here. You can see a molecule has at least 2 atoms in it. Sometimes they have many atoms in them. Molecules can get very big, but these are very simple molecules, and they can either be the natural units of an element. So in the world, you never see one oxygen atom floating around on its own. You just get 2 oxygen atoms going around together, so you get O2. And the same for hydrogen, nitrogen, and chlorine. They go around as diatomic molecules. Diatomic. Diatomic means 2 atoms. So those are the natural units of elements, but we can also get smallest units of a compound. So there you have water again, H2O. You have 1 oxygen and 2 hydrogen, and you cannot get less water than 1 molecule. If you cut that molecule up, then you do not have water anymore. So that is the smallest unit of water that you can get, 1 molecule. Okay, a neutron. So we've seen these before. Neutron is a particle in the nucleus that has 0 charge, and the nucleus is in the middle of the atom there, and in this carbon atom you can see that there are 6 neutrons. The neutrons are the blue balls in the middle. So different elements will have different numbers of neutrons, and although this is an old model of an atom, it is still useful for looking at what exactly is found. So what is the nucleus? Well, the nucleus is the center of an atom, and it is made from protons and neutrons. Here you can see a carbon atom with the nucleus, which we saw in the last slide, and the nucleus is in the center. And in an atom, we talk about the center of protons and neutrons, but actually we can talk about the nucleus of anything. Really, anything which is built around a center, we call that center the nucleus. You can talk about the nucleus of a family or a nuclear family. So sometimes in the nucleus of an atom, strange things happen. So for example, you can sometimes get a proton and an electron coming together to form a neutron in the nucleus. And that is just one of the strange nuclear reactions which happen. And yes, that is where we get nuclear energy from. Observation. So observation is looking at things carefully to learn more about them. And you can observe things in everyday life. Maybe you want to observe someone to see how they react. You want to observe your friends to see how they do something. And in science, observation is just the same, but observation has to be combined with recording, with writing things down and making sure that you can always go back to your observations. And those really are 2 of the most important skills in science: being able to observe carefully and being able to record what you observe, being able to write it down and look at it in an organized way. Organism. An organism is the scientific name for a living thing. So there are many different types of organism, and we have different names for them all. But plants, you can look at insects, or animals, or birds, which are also animals, it's true, or people, which are also animals, but they are all types of organism. And organisms can be very simple, like these single bacteria. These are single-celled organisms. And they can be very complex, like this incredibly detailed living body that we all have, with many, many different systems inside. Particle. So a particle is a very, very small piece of something. So you could have a particle of dust, a particle of sand in the real world, but in science, which is also the real world, in science a particle is usually part of an atom, and it can be electrons or neutrons or protons, or even smaller than that, things that make up neutrons and protons, like quarks or bosons or neutrinos. And all of these are particles which science has discovered really very recently. They are the things which make up the atom. The atom used to be the smallest amount of anything you could have, and you could not cut it. Atom actually means uncuttable in Greek. But then we learned that you can cut the atom, and inside you have subatomic particles. And we say subatomic because they are smaller than an atom. They are below the atom in size. The first subatomic particles we discovered were the electron and the neutron and the proton, but we have now discovered lots more subatomic particles that make up matter. So, back to the nucleus for the proton. And here is our friend the carbon atom again. And a proton is a particle with a positive charge that you find inside an atom. And here you can see that a carbon atom has 6 red protons at the center in the nucleus. And those 6 protons with their positive charge are balanced by 6 yellow electrons with a negative charge, so that this carbon atom has a 0 charge. If you take away one of those electrons, then all of a sudden we have a carbon ion, which we talked about before. But different elements have different numbers of protons, and in fact, the number of protons tells you which element you are looking at. So if there are 6 protons, you know you are looking at carbon. If there are 2 protons, you know you are looking at helium. Radiation. So radiation is a kind of invisible light energy. In fact, all light energy is radiation, but we usually call radiation the invisible kind that we cannot see. Some kinds of radiation can damage cells and cause serious illness. The radiation is what creates ions, and quite often those ions in cells can do seriously bad things. So radiation is something to be careful of, although the word radiation covers many different types of energy, and some of them are completely safe. So mobile phones produce non-ionizing radiation, so radiation which does not make ions. And non-ionizing radiation is generally thought harmless. Most people agree that non-ionizing radiation is not dangerous. But then you have ionizing radiation, which everyone agrees is very dangerous. And there are 3 kinds of ionizing radiation: alpha, beta, and gamma radiation. And we're not going to talk about those here. Scientist. So, a scientist is a person who does science, usually, but not always, as their job. Some scientists have been amateurs. Amateurs who do science for fun or for any other reason, but not as their job. So, to me, at least, and some people might disagree, but the great scientists are some of the greatest heroes of humanity. And here are 3 examples. You have Ibn al-Hazm, who is from the Middle East, around 1,000 years ago, and he was one of the first scientists. He wrote down the scientific method, which is the way that we do good science even today. Isaac Newton was one of the great scientists about 400 years ago, and he discovered how mass objects move and how light moves through different substances. So he looked at mechanics, the movement of objects, and optics, the way that objects affect light. And then Marie Curie, who is, you can tell, is a little bit more recent. We have a photograph of her around 100 years ago. She and her husband did the first work on radiation, and this is where we see why scientists can be heroes, because Marie Curie and her husband in fact both died because of radiation that they were working with. They did not know it was dangerous, and so they ended up dying from cancer that was caused by their scientific research. And even after they realized what was happening, they continued with their research. They wanted to find out exactly what was going on and what was happening with radiation. So very, very brave indeed. Solids. So we've looked at gases and liquids that are two states of matter. Solids are the third state of matter, and the molecules in a solid are held together very tightly and they cannot really move around, which means that solids are, well, solid. Solid can be used as a noun or an adjective, and solids are not all the same. Some of them are very easily broken, and some of them are very hard. So, for example, charcoal is quite soft. You can break it very easily, but diamond is extremely hard and is one of the hardest things we know. And what's very interesting is both charcoal and diamond are both made from pure carbon. They are only made from carbon, but the difference is how you put those carbon atoms together. Okay, so the next three words go together. And the first one is solute. A solute is a substance that will dissolve in a solvent. So here are some very famous solutes. These are sugar. And sugar dissolves very well. A solute will be a solid in a crystal or a powder form. So crystals like sugar and salt are good solutes that will dissolve easily. But anything that will dissolve in any liquid is a solute. Next word is solution. A solution is a liquid that has a solute dissolved in it. So here you can see a glass of water. Now if the solute is completely dissolved, then the solution will look the same as the solvent. So if you take a glass of water and put a spoonful of sugar in it, then in a few minutes the sugar will be gone. It will be invisible in the water. But if you taste the water, it will still be sweet. The sugar is still there, but it is dissolved, so you cannot see it. A solvent is a liquid that something will dissolve in. So again, you've got water. Water is a good solvent for some substances, but not everything will dissolve in it. And there you can see water with something that either will not dissolve, or maybe there is just too much of it to dissolve. So a solvent will dissolve things in it, but you can only dissolve so much of something before the solvent becomes saturated. The solvent has more dissolved than it can take, so then nothing else will dissolve in that solvent. Speed. Speed is a measure of how fast things are going. So here you can see a speeding car. Again, you can use speed as a noun or an adjective. And speed is measured in meters per second, at least in science it is. You can also measure it in kilometers per hour or miles per hour, which we sometimes do, but in science we very often use meters per second. We can also think of speed as a change in distance over time, because it tells you how many meters you travel in 1 second, or how far you go in a certain time. Substance. So, substance is a word we've seen many times, but now let's see what it means. Really, it means the same thing as matter, but the difference is in the way we use the word. So this is a little confusing. I will try and keep it simple. When we talk about substance, we can say the universe has substance, which means the universe has mass in it. And we can also talk about a substance. Oxygen is a substance, or the substance in that bottle is water, or something like that. We can talk about matter in the same abstract way. The universe has matter in it, but we cannot usually talk about a matter in quite the same way. A matter is actually something conversational. When we talk about a matter, we usually mean a situation or an issue, something we need to talk about, a matter to discuss, or a matter to sort out. In fact, we can use the word substance in this conversational way too. Velocity. So velocity is just like speed, except it also has direction. So we can say that this car has a speed of around 20 meters per second. So we know that this car is traveling 20 meters every second, and that is its speed. However, what if we also add a direction? We can say that the car is traveling at 20 meters a second northeast. And now we have given its velocity, because we have given a speed and a direction. In everyday terms, speed and velocity are used almost the same, but in scientific terms, speed and velocity are not the same, because velocity has direction. Visible light. Visible light is what we use to see. It's what comes into our eyes. It's a kind of radiation on the electromagnetic spectrum, and the electromagnetic spectrum is all the different types of radiation that we can detect. So we see visible light as 7 different colors, but other animals see the electromagnetic spectrum differently. Some see more colors than us, some see less colors than us. So light travels in straight lines, you may have heard, but it can be thought of as particles which move as rays, or also as waves. There's a light ray which just travels in a straight line, but here's a light wave. So the light wave travels in the same direction, which is called the direction of propagation. But the wave itself goes up and down around that direction. And trying to understand how light moves, we needed to design a new kind of science. And the more we learned, the weirder it got. This science is called quantum mechanics, and it really is the science of the very, very small. And our first look at how weird things were getting was when we first tried to work out how visible light behaves. So that is the end of our vocabulary list. As I said, there will be some important words left out, I'm sure, but I hope that that was useful. Bye bye for now.